Well, I've got something very special today. We're here to talk again about composability, but composability as it relates to VMware. And we can do some hardware composability actually from vCenter. And I've got some very special guests if you guys want to introduce yourselves.
Yeah, hi. This is George Wagner. I'm a director of product and technical marketing here at Liqid.
And I'm Reese Lloyd, Principal Product Manager here at Liqid.
Now, you guys make composable infrastructure. That's what we love talking about, and I'm super excited about composable infrastructure because it is definitely the future of the data center. When I can have just, a rack of equipment with a bunch of GPUs and storage and compute in it, and I can just decide which thing is connected where with software, that to me is the future. That's something to be incredibly, incredibly excited about. And you guys have that technology, and you've got all of the lumps that came with developing that technology, and it's an incredibly exciting thing. But I've noticed in our comments and stuff that a lot of people get confused because they're like, oh, that's a virtual machine. And I get why, because it's like with composability, you're adding hardware to a real machine by flipping some software bits. Like I flip some software bits and all of a sudden more GPUs are plugged into a real computer. But we're not really talking about virtual machines. We're talking about actual real bare metal hardware that you're inserting and removing. It's PCIe hot plug. It's like you've seen, the hot swap hard drives on the front, except we're hot swapping video cards without actually physically moving where they are. We're just changing which thing is connected where with it, like a software switchboard, basically. So can you guys tell me a little bit more about, that infrastructure and how it's like, on the bare metal side of things?
Yeah, so I think kind of a way to step back and explain it is that, I was in IT as you are now. This is but way back in the old days, Wendell, but it's always just been a pain in the butt to spin up servers, right? Every device is owned by a particular server. Those servers take 30 days to procure and spin up and takes weeks to scale. And when you're done using them, they're become, very expensive paperweights. I think virtualization was an answer to that. I think the cloud is an answer to that. But for the most part, we're still spinning them up, scaling them, and getting rid of them the same way we did, 25, 30 years ago. And that really comes down to the way that we design. We've always designed servers, right? I think we take it for granted that it's not very fast and it's not very, very efficient. So what we've done is taken the PCIe fabric or the PCIe bus. There, I let the cat out of the bag. The PCIe bus that resides in a server and expand it across the data center, right? Interconnect all the devices, PCIe devices, that is. So accelerators like GPU and FPGAs, storage, NVMe and Optane from Intel, as well as compute and even networking. And connect them over a PCIe fabric or even an Ethernet fabric or InfiniBand fabric, and then use our software to interconnect them to make servers of any shape or size. We call them even the impossible server, right? One use server with 16 GPUs, et cetera. But we're just lighting up connections between hosts and these accelerators or storage and compute devices to create any combination of systems, and that can be done in seconds. It can be scaled in seconds. And when you're done, you can liquefy them, right? Turn them back, melt them back into the pools that they are, and reuse them later. So it's really a new way to think about, creating the host servers that support your virtual environments.
Yeah, well, I think most people don't realize that PCI Express actually has its roots in a high-speed machine interconnect technology. It wasn't originally meant to be a system bus. It's just that that's all Intel had at the time, and they were like, all right, screw it. We're just going to, we need something this fast. Let's do it. And so Liqid is finally, sort of bringing it together. It really is an incredibly high-speed, incredibly low-latency fabric for connecting things. And like a virtual machine, like we're talking about VMware, and with a virtual machine, it's like I'm going to add a virtual NIC to that. And there's the distinction of like para-virtualized NICs or, an actual software construction, NIC. But when you add a NIC to a Liqid instance, well, I guess it could be kind of virtualized because you can run that over the fabric and there's not really a NIC there. But you could be really adding a real honest-to-goodness PCI Express device to a real honest-to-goodness host. And so if you're running like VMware plus something like containers, you've actually got a plug-in for vCenter for managing it like it's a virtual machine, but you're actually managing bare metal and the containers are running on bare metal potentially. So you remove the layer of, virtual, like the hypervisor virtual machine, and then containers inside a virtual machine. It's just a hypervisorless way to manage it, which is really incredibly awesome. So, can you talk a little bit about, sort of the workflow that you see and like how that integrates with like vCenter? Because being able to manage all of that from inside vCenter is huge.
Yeah. Yeah, I mean, I think so. The nice thing about taking what Liqid does in terms of composability and moving it into vCenter is it gives a vCenter admin that single pane of glass to compose physical devices in their environment and then build VM workloads on top of it. To your point earlier, that doesn't have to be exclusively ESXi hosts. You could have a mixed environment and still manage it all from within your vCenter environment. So if maybe you have 2 dedicated hosts that do nothing but AI and ML workloads and they run Ubuntu, go ahead and compose GPU resources into there. But then when you're ready to leverage those GPU resources for, say, VDI workloads during the day, compose them over into your ESXi environment, fire up all those VDI instances, and just go ahead and carry on. But it's all done then from that kind of one single pane of vCenter glass.
That's awesome. So I could with with scripting, maybe vRealize. I mean, there's some I's we'd have to dot and T's we'd have to cross. But theoretically, if I were a really good IT administrator, I could build something where it's like, okay, everybody's working 9 to 5. I'm going to have 90% of my VDI resources available with my GPU accelerators. But at like 5:30 p.m., I've got a script that kicks off, and then now we're going to use those GPU resources for the research scientists in the machine learning lab. I mean, is that what you're saying?
Yeah, absolutely. And I think the other cool thing to point out is, we have a vCenter integration now. We've got a command line. We've got a web user interface. Those are all built on top of Liqid's API, which means all of your scripting can tie into that same API. And you can either do it via the vCenter user interface or script all of that as you described and have it all integrated into a single workflow.
So I could have one set of GPUs that's basically anytime they're not being used, they're being used for machine learning workflow or research or whatever my my machines need. And basically, there's no wasted resources inside the company. Well, it's going to be huge for edge compute too, because companies like VMware are pushing. It's like, okay, you got your on-prem stuff, but we're going to let you stretch a cluster out into the cloud and do all that kind of stuff. So you can kind of mix and match there as well, couldn't you?
Yeah, absolutely. And I think the other thing to point out about edge, the challenge with the edge in a lot of cases is the edge is in remote places. It's in places where humans aren't. Wouldn't it be nice if rather than sending somebody out to move an NVMe device from one system to another or add a GPU, you simply compose those resources in. Nobody has to go into, the isolated data center where those things live, and you get the benefit and the efficiency from it.
Yeah, I think, judging, this is not our first video on this, and another question that comes up a lot is, well, what about the bandwidth? Isn't there, some kind of bandwidth consideration or bandwidth constraint? And, I really, it's more than we can get into in this video, but I really have drilled down on the numbers with you guys, and I was surprised because when we're talking about PCI Express bandwidth, it's actually more than most people realize. Especially for these kind of workloads. Can you speak a little bit to, well, but wait, isn't there enough bandwidth? I mean, you guys have done the work.
Yeah, absolutely. I think there's 2 answers to that question that are interesting. The first is, as you note, the PCIe bandwidth is huge. It's on the order of gigabytes per second. There are a few workloads and there's few devices that can truly take advantage of the bandwidth that the PCIe bus offers. The other side of that, though, is there's a lot of workloads that aren't bandwidth intensive that still need those resources. There's a lot of GPU related workloads where the amount of data you actually need to transfer to or from that device is fairly minimal, but then the device itself needs to be doing a lot of work on that data. And realistically, PCIe supports both of those workflows equally well.
Yeah, I think we were doing a simulation a couple of weeks ago, it might be months now, and I was really surprised that, with the software tuning, because it is a PCI Express fabric, some of those GPU workloads can actually borrow stuff from the memory and other GPUs. And so while it's like a local execution on a GPU, another GPU can talk to yet another GPU. And that bandwidth doesn't really count against any of the bandwidth to your host. It's a basically device-to-device communication. And so even that is an absurd amount of bandwidth, but it's not centralized. And so you get a multiplier effect on how much bandwidth you actually have. At least that's my take on it. I mean, what do you think?
Yeah, George, do you want to jump on that one?
Yeah, no, absolutely true. So we have a feature called peer-to-peer, P2P, and it allows for direct communication between GPUs. They can share memory, across between enclosures. So we talked about in the last video, I believe, that we can distribute those or disaggregate those GPU resources into enclosures. They can connect between devices in a single enclosure, across the fabric into different enclosures. To your point, Wendell, and we're confirming it, absolutely, you do get a multiplier effect on bandwidth by doing that.
Yeah, the pictures, like the rack pictures of like, here's a Liqid rack, and it's just like, what are all these wires? It's like those are all insanely high speed PCI Express interconnect
Yeah,
because it's basically an n-way matrix, so everything can communicate with everything else as fast as it possibly can. So the fabric's not the
exactly.
not the bandwidth problem. It's just the
No,
number of devices. But
Yeah.
yeah, I mean that's really really exciting because most people don't realize that you can have a little bit of non-locality. Now you're going to have trouble when you're composing stuff in another data center, but I understand you guys have also tried that too, and it's not as terrible as you might imagine.
Yeah, absolutely. I mean, it depends on what your device and what your system can handle in terms of the latency between those. But really, the sky becomes the limit in terms of as long as you've got workloads that can handle it, we can certainly compose it.
right.
The limiting factor is basically the speed of light, and there's nothing any of us can do about that.
Yeah,
Unfortunately, no.
we're
Well,
working on it though.
vCenter and that integration, I understand that you've got kind of a demo of what that looks like. So I think probably a fair bit of our audience is familiar with vCenter, but let's take a look.
Yeah, absolutely. Let's take a quick look into that. So what we wanted to do is folks that are familiar with Liqid are familiar with our Liqid Command Center. This is our web user interface. What we wanted to do is take the composability aspects out of there and put them natively into vCenter. And the way we've accomplished that is leveraging the vCenter plugin architecture. And really what we've done is taken that same sort of view that you would get in Liqid Command Center and bringing that into vCenter. So what we have here is I've got two hosts that are set up on this same fabric. And then I've gone ahead and created a group that contains both of those hosts. But then also we've got some devices as well, right? We've got a GPU, a couple of SSDs, some other things in this environment. And what I wanted to walk you through is just kind of give you an idea of what it looks like to actually do some of the things we've talked about. What does it look like to actually take a GPU from an environment and compose it into an ESXi host?
So to help our audience understand, you've got two physical boxes that are connected via PCI Express fabric. It's not really a network interface or anything like that, and it's connected to the Liqid fabric where you're hosting all of these devices. And so the physical servers right now are configured with those PCI Express GPUs and SSDs through the Liqid fabric, but we're talking about two physical servers with physical connections to a physical box that's allowing some, but not all of its resources into these two physical machines.
That's an excellent summary. So the best way to think about this from kind of an architectural point of view, the two hosts have HBAs that connect them to the Liqid fabric. We have an enclosure that also has HBAs in it that houses all the GPUs and the NVMe devices in this case. Then we use the Liqid fabric to compose those devices from within that enclosure into the physical hosts, make those devices appear as though they were local to those physical hosts.
So it's kind of like a switchboard operator, basically. There's just, but you're doing it electronically.
Absolutely. That's actually a really good analogy. Plug in over here in this device, plug in this host, and those can now talk directly to each other. So from within here, let's go back over to our hosts right quick. I've got one host in maintenance mode already. Unfortunately, ESXi does not support hot plug of PCIe GPUs at this point, so you do need to shut these down. So we'll go ahead and put this into standby mode.
Only NVMe, and we only just barely got NVMe hot plug support.
Exactly, and we're hoping it's coming soon. It's something that we are in conversations with VMware to encourage them to bring this support in. I think it would make for a much more powerful workflow for customers to be able to do all of this while these are live, and also just reduce cycle time, essentially. How quickly can you do this? Once this system is shut down, what we'll do is we'll simply go into the Liqid plugin, add that GPU in, and reprogram the fabric. Super straightforward and simple. Generally, these take about a minute to shut down. We'll come back and show you the next step once that's done.
Yeah, this is pretty exciting to think about that we are basically hot plugging the hardware into the physical enclosure. I mean, we're waiting on the software side of it a little bit, but I'm thinking about a world where maybe I've got like Kubernetes or something like that on bare metal, and I can kind of manage those bare metal machines actually from vSphere in terms of like from vCenter in terms of which physical device is connected to which physical thing. So I'm sort of having the best of both worlds of that. I don't have to run Kubernetes inside a virtual machine anymore, potentially.
Yeah. Absolutely. Yeah, and it also gives you the ability to really tune your physical system to match the workloads you want to run on it. So you might have workloads that are super GPU intensive and can benefit from having, say, 10 GPUs composed to a single server. And then as you branch out, maybe the next step in that same workflow only needs one GPU per host, but it needs a lot of CPU resource in that case. Spread those resources around and let those workloads kind of come and go to match the hardware that they need at the time.
Yeah, I'm thinking about like real world scenarios I've been through where it's like, okay, we're starting with our specialized host, which is like a 2U server with a couple of half height, half length, accelerators of some kind, like video accelerators. They're usually like Tesla type GPUs, and then it's like, okay, we're going to scale that up. We need 2 or 3 more in the thing, but with this, if I've got the Liqid fabric and I discover that I need more cores to feed the number of GPUs that I have for slots in the Liqid fabric, I could just add more commodity pizza boxes and rebalance my GPUs. And that seems like that's going to be way less headache.
Absolutely. Yeah, it really lets you select the server size that's best for you, as well as the number of GPUs or other devices, rather than having to pick a server that will fit the number of devices you need. It really gives you a lot more flexibility in terms of composition.
Well, a lot of the time, as the computer janitor dealing with that, I don't know that up front. Like, I need to actually run a little bit of real world workload in order to find that. And then sometimes it's a costly mistake. It's like, oh man, we needed to go with the 4U servers because I need to put in a lot more GPUs per socket. I'm stuck. I got to throw these out.
Absolutely. Yeah, and we're seeing customers as well that want to run like a Blade Center environment, for example. They simply don't want large servers in general. They can fit a lot of density from a Blade Center and then compose in resources like GPUs that you simply just wouldn't be able to put in that box at all.
Yeah, this is pretty exciting. All right, so what are we looking at here?
So this guy shut down. Just a quick review of the PCIe devices. None of the devices we're going to compose in are present just yet. The other key way to show that is it doesn't have the graphics section, which shows up once you compose in a GPU. So we'll go back here to our Liqid plugin, go to that host, which is conveniently named with its IP address, and simply all we do here is hit edit. So from within edit, we can see we've got the machine already defined. What we're going to do is just pick the GPU resource that we want, click add, and then hit reprogram. What the reprogram step actually does is that's the switchboard you mentioned earlier. That's Liqid indicating to the fabric to make this electrical connection between the device and the host itself. Once that's done, which takes about 20 seconds, we can simply go back here and fire this host back up again. And as it...
Not to beat a dead horse, but like what's happening here is so magical because there's no trickery or anything. It is literally a PCI Express native connection. We're not packaging up PCI Express into some other thing and then deploying it or packaging up PCI Express into some other interconnect and then depackaging it with proprietary software. This is literally just PCI. This is the type of PCI Express switching that you have at a hardware level, even inside a single server. Like when I am in Linux and the command line, I'm like, I need to reset this host bridge because something locked up. This is exactly the same functionality that's in the PCI Express spec, and you guys have built all this special sauce around it, and that is what makes me so excited for this, is that it's not like hocus pocus. This is what it's literally built to do.
Yeah, absolutely, 100%. This is literally the equivalent of you had sent an engineer to the data center, asked them to take a GPU out of a box, put it into the server, put the server back in its place, go back to their desk and keep on going. We do all of that without ever leaving a desk, without ever needing to send somebody to the data center to do that.
Yeah, I mean, and it's a native PCI Express full bore. The PCI, the latency that you would expect with PCI Express, because there's no protocol translation or anything like that. I mean, even just anybody that has any experience working on like 25 or 100 gig Ethernet knows that there's all this crazy technology now built into Ethernet, like RDMA, to just try to hide the latency. But you don't have to deal with any of that because this is native PCI Express. You avoid those problems by not doing it that way.
Yep, 100%.
So I like the fact that you brought up the whole, that we are utilizing native PCIe, right? This is not any type of proprietary hardware devices. The enclosures that we use are, strictly industry standards, using strict industry standards. So it's I like your analogy of the switchboard operator. That's exactly what's happening. I'm going to steal that as a marketing guy.
That's
Perfect.
fine. It's totally fine. I've put a lot of thought into this. I mean, I've been putting a lot of thought into this for the year or two that Liqid has been on my radar because I'm a little bit aware of the history of PCI Express, but I'm also aware of how insanely buggy PCI Express and the different implementations are. And you really have to, people are going to look at it and be like, oh, I can do this, but then they're not going to be able to, and then somebody's going to buy you guys for $1 billion or $40 billion or something crazy, and it's just going to be like, yes, it was all worth it.
Right. There's a lot of work that goes on in the background just to make sure, because we're dealing with, mission critical systems. And so we need to ensure that, this I'm sure when PCIe was developed, they weren't imagining this occurring. Right?
They laid the groundwork, but there's a lot of details that are like,
Right.
I mean, I've told you guys about, the reason that I'm in on this is because of the whole GPU thing and sharing a GPU between virtual machines and doing this at a very ghetto fabulous level with just a board that has a lot of slots.
Fabulous.
So
I love it.
And I, all the bugs that I've tripped over, and just even reading this PCIe spec, because Intel's management engine, for example, on dealing with AMD GPUs, it's the step one is, you do this and you save the registers and blah, blah, blah. And then you need to reset the host bridge and then that kind of thing. So Intel has their management engine do that. The management engine will read the PCIe status registers, reset the host, and then it will rewrite the status registers. The actual specification says, the register should be saved and loaded when you do a reset. And it was handled in the management engine. So in the Linux kernel, it just calls PCIe reset function, and the management engine handles everything. On the AMD side, in the first implementation, they just reset. They're like, "Oh, you want to reset? Bam, we reset." It's like, what's in the control registers? I don't know. So they were like, "Oh, we're responsible for saving and restoring those registers." The spec doesn't say that. It just says they should be saved and restored. And it's like, well, if you're not doing it at the platform level, is it up to the Linux kernel? And they're like, yeah, that's what we thought. And it's just like, oh my God, please make it stop. So, all right, ESXi has finally booted up. We just need to refresh the interface.
Yeah, we'll go into our PCIe devices here. And there's our NVIDIA card here. And we should get our graphics menu popping up here as well. We'll see, this may be there it is.
Yeah, it's a React application, so it's like, oh, I can't hard refresh.
Exactly. So yeah, I mean, the cool thing is, as far as ESXi is concerned, that GPU is physically resident in that server now. It can be used in the same way, whether that's vGPU capabilities, MIG capabilities on some of the nicer, newer GPUs. All the things that you would do with a physically installed GPU, you now get to use via this composed GPU.
Yeah, and well, this is a GeForce GTX, because this is your demo system. But
Exactly.
If this was like a Tesla V100 and you had grid and all that, this would be 100% ready to go. Because again, PCI Express, I can't drive that home enough. This isn't your plug-in doing this. This is a literal PCI Express plug-in, or PCI Express connection. The plug-in is only managing which thing is actually plugged in. It's not doing anything else. So anything that you would expect to work at a PCIe level will work, which I think is important to drive home, because with FPGAs and data acquisition cards and crap like that, it gets real sketchy real fast. But because it's a native PCI Express connection, it is the most guaranteed to work.
Yeah. And some other interesting workloads there too are things like, envision you have an NVMe device that you want to load up with 16 terabytes of data. Then you want to move that data somewhere else. Rather than actually copying the data, just move the device itself to the next server that needs it. There's no data copy time because it's just resident on the PCIe device by default.
Yeah, that's huge. I mean, that's hugely valuable, and you're managing it from within vCenter.
Absolutely.
This is awesome. This is awesome stuff. So we're looking at this from inside vCenter, and I see the composability and all of that. But I could also have, a mixed host environment. So we've got these two ESXi hosts. All right, fine, and we're composing infrastructure into that. But we could also have a host or two or three that are not part of vCenter. What does the Liqid command center look like that if I want to like recompose this into machines that are sort of outside the purview of your vCenter plugin?
Yeah, no, it's a fantastic question. And the short answer is we tried to emulate as much of the functionality as we could within the vCenter environment. So a lot of what you'll see look very similar within our command center environment. So here's our demo group. Groups for us are a way of grouping together resources, whether those are hosts or devices. We can also leverage those to have multi-tenancy within the system. So if you wanted to have your finance group and your marketing group have separate groups within Liqid, and they only have the purview over the amount of resources that are in each of their own individual groups, we can do that as well. But then in terms of composability, yeah, it's super cool. In going down the path even further, we could have a vCenter group that is maybe just ESXi hosts, and then maybe there's an AIML group that's controlled by your research group, something like that, and allow them to only leverage their specific resources. But then once you're in Command Center, the rest of it looks very similar. So we can see here's our one CPU or one GPU. We can drill in a little bit deeper if we want to see some more specifics about, what does this GPU look like? Here it is. It's the 1080 Ti that we composed in. Those are available via the Liqid Command Center user interface as well.
This is really cool. This is really, really cool stuff. So you could have, your manager that's impossible to deal with in some other, business division, and it's like, all right, your budget, you've ordered these things, you can use this however you want, and that could be one group. But then you've also got the reserve group. So if they come to you and they're like, oh my gosh, I need all this stuff, you can basically just hit all right, fill out requisition form 37A. And it's like, all right, I'll just give you some more GPUs. And it gives you a nice buffer because it's a little different than procuring hardware, especially like now with the global situation. If you already had your infrastructure structured that way and you needed to scale, especially for something short term, it's a matter of just juggling the resources you already have electrically as opposed to physically.
Absolutely. And it also, it gives you some visibility into, a group ordered a GPU 3 weeks ago. They used it for a week. The project they were doing didn't end up panning out. They shut the server down. Well, now you've got visibility into that. You can simply recompose that GPU and put it somewhere else, put it to good use. If that project ever comes back online, cool, we'll compose your GPU back in, but you're not losing kind of the cost of that sunk cost in that GPU.
So the project that the marketing team, they were going to use AI to sell products better, but it turns out there's 10 GPUs just sitting there. I can see that now as an administrator and say, okay, we got to repurpose these GPUs because they're really suffering in the VDI department. I'll let you keep 2. I'm going to take 8. And if you guys figure out how to run whatever crazy AI thing you were thinking of, I'll give them back. But in the meantime, this is going to run in the VDI. I love the monitoring and analytics possibilities for this as well. No wasted infrastructure.
Absolutely. That's our number one thing. And George can speak to that a lot in terms of just really getting efficiency out of the data center components that you paid for.
Absolutely.
This really does look like it would make it super easy to add a lot of stuff to a single machine. I want to add 16 GPUs and 12 NVMe. No problem. It's just point and click.
Absolutely.
Exactly. Yeah, we did a demo for ESG a while back where they wanted to see it in action, and we were able to assign 16 A100s to an Intel server that was 1U half width. So imagine that in reality, what that would look like. Well, it's impossible, right? Yeah, no, we were able to do it.
That couldn't possibly work, but
yes.
it does.
Yes.
Although I think you'll find that system designers sort of make assumptions like, oh, we won't need that much bar space, and it's like, I don't know about that.
Right.
That's a lot of fun. Well, that's really. I mean, that should give everybody that's watching this something to think about. I mean, whether you're the low level grunt that's having to fetch things in the data center off hours because you're on call, or you're the administrator at the Fortune 500, sort of managing things. There's really a lot that you can take away from looking at composability. I mean, density and infrastructure management, it's going to be transformative. This is what data centers are going to look like, in my opinion, in the next 5 to 10 years. And there's everything moves in cycles. Originally there were mainframes, and then there were desktop computers, and then we're in kind of that. Everything went to the cloud, and now marketing people are saying, oh, everything's sort of coming back from the cloud. I don't really think it's that. I think it's that the speed of light and edge compute and having the compute happen where the data is sort of becoming a thing, and being able to not have super specialized hardware in the rack, but having your compute and storage and GPU and FPGA and any other fun thing, sort of like a rack or two or three in a data center, and having them be really close together. It really opens up a lot of possibilities for the software side of things and software management. So if you think about like all this gives you, you can have a generic container of compute and storage and GPUs in certain proportions, and as a generic Lego building block, you could deploy that in the event of a disaster. You could deploy that in the event of an expansion. You could deploy that in the event of anything. And you guys are in the trenches doing this, and so I'm sort of vicariously very excited.
Thank you. Yeah, it's really cool stuff. Reese and I are both technologists, and I think this is one of the first companies I've worked at where everyone we talk to just has interesting feedback for us. It's something that's new. It's something that's interesting and topical. So very excited to be doing this.
That's definitely the audience engagement challenge this time, is like composable infrastructure. For what you do in your job, how could composable infrastructure make your life easier? I mean, there's so much that I do where it's like, if I could just click a few buttons and give them a little bit more resources or shift things around and be like, okay, that department, they laid off some people. They don't need this anymore. I can just move this over here. And I don't have to do anything other than hit a few buttons. That's great.
Absolutely.
Cool. Well, thank you both. It's been really awesome. You can check out liqid.com for more information. And, if you're in a position to like, these are, if you have to ask, this is expensive stuff, just so you know, but it's good stuff. But definitely reach out to Liqid if, you're looking for something like this. It might tick a few boxes, in other words. Would you say?
Absolutely.
We'd love you to.
All right.
Absolutely. And thanks for your time, Wendell.
No, thank you guys. It's been really awesome. I really appreciate it. And thanks for letting me talk your leg off. I get sucked into that sometimes, and I just get so excited. Thank
Absolutely.
you. Thank you both. See ya.
Bye-bye.